I originally tried the AM-GM inequality on this. It seemed natural. It seemed like it would work. Let me write it down real quick what it is for this case. If you have real numbers A plus B plus C, I think they need to be positive real numbers. Okay, and then divide by 4. This is the 4 variable version of what they call the arithmetic mean geometric mean inequality. This is guaranteed to be greater than or equal to the 4th root of the product. I've always thought this is one of the coolest inequalities in the world because it relates directly addition and multiplication. And notice the index of the radical 4 appears here, and it appears as a divisor here. But now we have the product, A, B, C, D. And it seemed like this would work. I couldn't get it to work. Somebody, if I made a mistake, let me know. I couldn't. It seemed like this would lead to the answer, but I did the manipulations. I tried it with 34 over 105 squared is A, 1/3 squared is B, and so on. And I never could get anything to happen, okay? So I switched to our old friend and old faithful inequality, Cauchy Schwarz. Okay, now it holds for any real numbers at all, okay? You don't have to worry about the sign of the real numbers. And here's one of the statements of the Cauchy Schwarz inequality. And this is its formulation for real numbers. It has a formulation in terms of vectors also. Now, notice that I put strictly greater right here. And right down here we have greater than or equal to, right here. Okay, now notice there is an equality condition, and that's if all of the coordinates have quotients that are equal to each other. For example, well, I'll just write it down with respect to this problem. If we choose 1 to be in front of each one of these, you know, a 1 here, a 1 here, a 1 here, we can see very quickly that 1 over 34 over 105 certainly does not equal, let me put a does not equal symbol here, to any of the rest of them, okay? I'll put 1/3, but it's all the way across. Do I have room here? Does not equal 1/5. Well, it should be 1 over that, I'm sorry. 1 over this, 1 over that. And you get the picture, right, folks? It does not equal, so that is why it's going to be a strictly greater than condition here. Okay, and I left out 1 just because I'm running out of room right here, folks. But again, this condition is not satisfied if we choose 1s, just plunk 1s in front of this expression. And I'll show you what I mean by that in just a minute. It's called the 1 trick in Richard Steele's book. And you can see how I put 1s here, 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 and here. And it seems rather stupid, but you see what happens right here. You see you get, this actually would be a 1 squared right here if you take a look at the formula up here. Okay, if you take a look at the formula, this would be 1 squared, this would be 1 squared. And again, what I've done is I've written this side right here and this side right here. I've just written it in exactly in the form that you see. Okay, there's not much to say about it really, but you can see why the 1s are very important for this type of setup. All right, and it seems like you're cheating, but it says for any real number, so you can pick 1s even if they're not visibly present in the original expression. Okay, now the rest of this is just fairly straightforward here. What I did, the only real work I had to do other than just rotely substituting into this Cauchy Schwarz expression inequality is find the common denominator right here. Notice that 1 over 3 is equal to 35 over 1 over 5. 1 over 5 is equal to 21 over 105. And 1 over 7 is equal to 15 over 105. Okay, and in this particular case, they conveniently add up to 105. In other words, this would be 105 in the numerator if you sum those values up over 105. Quantity squared, but that's equal to 1. Okay, but you see the result follows very quickly. This right-hand side, it's greater than or equal to this. So if you divide through by this 4 right here, you see this would add up to 4 right here. If you divide through, you get the desired result. Okay, it's such a hassle to write it down, but we're at this stage right here. Okay, we have all of this, and this is our original, if you look here, this is our original thing we were trying to prove, the left-hand side. So let me go ahead and take the time to write that down, I suppose. So you'll have 34 over 105 squared plus 1/3 squared plus 1/5 squared plus 1/7 squared. Right? And you see that was next to these 4. So you have 1 plus 1 plus 1 plus 1 is 4. So if you divide through by the 4 you end up with this statement right here. Okay, folks? So it's QED. And I don't think it's particularly sharp, and it's strictly greater. It's strictly greater. I just wrote down greater than or equal to. But it is strictly greater because of this condition I told you about that is not supported. When you take the ratios of these values, none of them are equal to each other. It's essentially saying they're all points on the same line, if you want to think about it more geometrically. But anyway, that does prove it, folks. Again, it's called the one trick. And like I said earlier in the video, I don't see why this thing, which is referred to as AMGM, arithmetic mean, geometric mean inequality. I mean, it seemed like it was made to order for that. There's something I'm missing here. Maybe I just made a mistake in my calculations or whatever. But I tried that first because it seemed like a natural fit for this setup here, but I couldn't get it to work. So if somebody has the time, try to work that and make a comment. Okay. Thanks for viewing.